Hello student. In the beginning of the 20th century, a path-breaking experiment was conducted by Robert Millikan and Harvey Fletcher. So they did this oil drop experiment to establish the magnitude of electronic charge. So let's learn how this was conducted by both of them and what were the significance of this particular path-breaking experiment. This experiment was designed by Robert Millikan and Harvey Fletcher. They used an oil chamber, which you can see in this pic, to conduct the experiment, and the main purpose of this experiment was to find the charge on electrons. Basically, they wanted to find the value of E, and this experiment proved to be a path-breaking step which helped us in finding the structure of an atom. Let's talk about this experiment and let's find out what he did and how he did. So a chamber was taken. So in this chamber we have an atomizer, right? And from the atomizer we have a lot of oil droplets are formed. Now these oil droplets will slowly go towards the condenser. You can see that these are the plates of the condenser or capacitor plates. So when you observe them through a telescope, we find that they acquire a constant speed. When they are falling only under gravity, they acquire a constant speed. Now let's have a closer look. When the oil drop is falling under gravity, the various forces acting on it are its own weight, right? W, which is like mg, a force which opposes its motion downwards. You know that air, right now we have got this as air. Okay, so when it is falling through air is a fluid. So whenever something falls through a fluid, it always opposes its motion with the force known as buoyant force. Remember Archimedes' principle. So we find that various objects are quite lighter in water or in other liquids also. So the same thing is happening here. So it is going to have a buoyant force which is in upward direction. In addition to that, whenever an object travels through a liquid, we always get a viscous drag opposing its motion. So Fv is the viscous drag and Fb is the buoyant force. Now since the droplet is falling with a constant terminal velocity, it is a constant velocity, obviously your acceleration is 0. Now it means all the forces, that is the downward force and the upward force, they are balanced. So we can say that W is equal to Fb plus Fv. Now putting all the values over here, Milliken and Fletcher, they were able to successfully calculate mass of the droplet. I'll give you a hint how they found it. Weight is mg. Buoyant force, we can take it as m dash g, where m dash is the mass of the air displaced by this droplet, and viscous force is taken as 6 pi eta rv, where eta is called coefficient of viscosity. In this case it will be for air. R is the radius of the droplet. V is of course the terminal velocity which experimentally they found out. Now mass is nothing but volume into density. So it's volume of the droplet into density. Say density of oil is rho times g is equal to volume of air displaced, which is going to be same, density of air times g plus 6 pi eta r v. Volume you can substitute as v is equal to 4 by 3. By substituting here, with the help of this we can calculate r. Now after finding r, again we can use m is equal to into density of oil. So now mass can be calculated with the help of this. So once the mass was calculated, then in next part of the experiment what we did, he connected both the plates with a high potential battery such that the upper part was positively charged and the lower part was negatively charged. Then he used an X-ray source which has the ionizing radiation. So when it passes through the oil droplets will acquire negative charge. So basically what happens is, because of the X-ray radiations, they knock off electrons from the air molecules. So some of the electrons are then trapped by the oil droplets and they become negatively charged. So now let's see what happens. Let us say the distance between the plates is d, right? And the potential that we had adjusted here is that we can of course find from the device. Now what happens? We see that few of the oil droplet, they get suspended. So what happens is the oil droplet acquires some negative charge. Now you know that negative and positive, they attract each other. So what is going to happen is a new force, that is electrostatic force, will be created inside the oil drop, right? And we already have the weight acting downwards, buoyant force which is acting up, and also the viscous drag, right? Now you see, after calculating everything, since the oil droplet is very small, so if we consider that, you know, for some time that viscous drag and the buoyant force are very small, so we can approximate this for our own convenience and simplicity. Let's approximate it like this. Let's remove the buoyant force and viscous drag. We are doing this only for simplicity, right? So therefore now we can say that your electrostatic force is balanced by gravitational force. So we can write Fe is equal to your Fg, that is the gravitational force. Now electrostatic force is given as the charge acquired by the droplet multiplied by the electric field that is generated because the condenser plates are connected with a high potential device. Now that is equal to what? Mass into gravity, acceleration due to gravity. Now again, relation between electric field and potential is V is equal to the electric field. The electric field is always directed from positive to negative. This is how your electric field is given. This is the electric field into the distance of separation, which in this case is d, right? So your E can be written as V by d. So this equation becomes Q V by d is equal to mg, and if you rearrange it, we get Q by m is equal to g d by. So by substituting the values of g, d and v, we can find the charge to mass ratio. So once your Q by m was calculated, and we have already found that Q is equal to n times E. Now we can write it as n times E by m. This E by m value was already calculated by Sir J.J. Thomson, and he found this out to be 1.75 to 10 to the power 11 coulombs per kg. So by comparing these two, it was established that n is an integer. So with the help of this, we found out that E, the charge on electron, was 1.602 into 10 to the power minus 19 coulombs. Mass on electron was established to be 9.109 into 10 to the power minus 31 kg. Now let us quickly summarize the significance of this oil drop experiment. First, it confirmed that electronic charges are quantized in nature. So the charges are just not any random values. Rather, they are integral multiples of the charge on one electron, and hence they can be called discrete packets. Most importantly, this experiment helps us in determining the charge of an electron. Today, this electronic charge is one of the most fundamental constants of physics and extensively used in various calculations. This experiment also validated the existence of subatomic particles. That means matter is made up of not only atoms but of subatomic particles. This experiment also advanced our understanding of electromagnetism. Now we started understanding how a charged particle is supposed to behave under electric and magnetic fields. This in turn not only helped us to find the fine structure of atom, but also helped us under different domains which were being parallelly studied in various experiments of physics and chemistry. So dear students, now we can conclude by saying that this breakthrough oil drop experiment paved way for both modern physics and quantum physics. See you again. Happy learning.